Hey guys, today we're going to take a look at the slope of a tangent. Okay, so we're looking at the tangent line to a curve at any point. We want to be able to find the slope of that line. Now you did discuss this in advanced functions over and over, I'm sure, where we talked about the instantaneous rate of change. So, before we begin, this first page is a bit of an investigation. So I want you actually to work through this first page by yourself or with a partner, or if you want, or you can even use Google or something to look up any answers that you can't remember. But I do want you to complete this first page before we begin with the lesson. So if you haven't done so already, I do want you to pause the video, go complete that, and then come back. Okay? So let's begin. So the first thing we're going to look at here is we're going to find, and this is the same curve that you should have done in the investigation, we're going to find the slope of the tangent line for the function f of x equals x squared at the point 2, 4. Okay, so right here I've already written the equation for slope that I'm sure you remember from back in grade 9. The other thing that we're going to do before we begin is we're going to write out what the 2 points we are, because of course you need 2 points to be calculating the slope. Now, because we want it at a tangent, there's really only 1 point involved. And that's okay, because we're going to come up with a way of calculating it with just 1 point. So here's how we're going to do it. So our first point is we're going to label it as well, our x value is 2, and our y value is 4, but I'm actually just for now, I'm just going to write it as f of 2. Okay, and you'll see why as we go. Okay, our second point, I'm going to label it, okay, well, we're going to take, the first point is at 2, and we're going to add h. Okay, and then that means that our y value will be f of 2 plus h. So the idea is, I'm going to use these 2 points to calculate the slope. But what I'm going to do is I want h to get smaller and smaller and smaller. Okay, so what I'm going to do is I'm actually going to write it as the limit as h approaches 0. Okay, so on top we'll have f of 2 plus h minus f of 2. And on the bottom, we'll have 2 plus h, and then we'll have minus 2. Now, before we even go any further, I'm just going to leave the top how it is, and we can simplify that bottom, and this is the form you're going to see this in more often. So we'll just leave the top how it is. Take a look at that bottom, and we're going to say, well, we've got 2 there, and we've got minus 2 there. So those actually just cancel out. They add to 0. And so we can just say that there will be an h on the bottom. Okay? So now right off the bat, you're going to notice that we are doing a limit as h approaches 0. So obviously we can't just use direct substitution here, because then we'd be dividing by 0. So we're going to go and we're going to use those limit sort of methods that we talked about the other day. And so to begin with, we're just going to sub in these x values into our function. So our function was x squared. Okay, our function was x squared. Okay, so we're going to call this 2 plus h squared minus 2 squared all over h. Okay. So we're going to expand our binomial here. So we have a limit. Remember, you have to write this limit part every single time, whether you want to or not. Okay, and we're going to expand this, so we'll have 4 minus 2 times h times 2, so it'll be minus 4h plus h squared. Okay, and then we'll have minus 2 squared is 4, and then on the bottom we'll have h. Okay? So now, from here, just like we did with the bottom up here, we're going to go through and we're going to say, well, we got a 4 here, and we're subtracting 4, so those are actually going to add to 0. So we're just going to have negative 4h plus h squared all over h. Okay? Just a bit of a note for when you are, just for communication. Remember, your equal signs, you want them all to line up. You're not supposed to be writing across like that. So if you do run out of room, what you're going to do is you're just going to take an arrow, you're going to put it up to the top, and you're just going to pick up where you left off. Okay? So we're going to have equals, and a limit, h approaches 0. And what we're going to do is we're going to look at this, and the method that we, hold on, I got a hand in the way. The method, I don't remember which method number it was, to be honest, but we're going to look at this, and you'll notice that we can actually factor out an h from the top. So what we'll do is we'll write h, and we'll have minus 4 plus h all over h. Okay? And so from there, we can say, well, hold on, we got an h on the top, an h on the bottom, and so it's the limit as h approaches 0 of negative 4 plus h. Okay? And from there, we can now just use direct substitution, and we can see that the answer is going to be negative 4. Okay? And that's all there is to it. Piece of cake, right? So you can see that these kinds of questions, there's a lot of steps, and often people will try and skip steps because, especially once you get going and you've done several of them. But I do want to encourage you to show as many steps as possible because it does make it harder to make mistakes if you're showing more and more steps. Okay, so we've kind of got. If we scroll down here, we've got a little picture that's just kind of illustrating what we just did there. Okay, and I realize that this picture kind of sucks and it's a little hard to understand, but so we've got our curve, okay? Y equals f of x, and you can see it starts, it goes down like that, okay? Well, I guess it's going the other way, but whatever, okay? And you can see that what we've done is we've got this secant line cutting through it like that. Okay. And what you'll remember from the last semester, hopefully, is that that would represent sort of an average rate of change between this point and this point. Not sort of an average rate, it's exactly an average rate of change. Okay. And you can see, so our first point here, where we're interested in, is at A. And you can see we've drawn the tangent line here. Okay, so that's the line we want the slope of. And so we've gone over by H to get a second point. And the idea is, as H starts here, but as we move H in closer and closer and closer, this secant line is going to get closer and closer into turning into the tangent. And although it'll never actually turn into the tangent because, you know, until you're actually on top of the A, we can get as infinitely close as we want. And that's the idea behind this, is that's what these limits are about, is about being able to take that and get it as infinitely close as possible so that we can actually calculate what that slope would be. Okay, so in general, what we're going to say, if we scroll down to our box, so in general, the slope of a tangent as a limit to the graph y equals f of x at a point where x equals a and y equals f of a, or f of a rather. Okay, you're going to say, well, that equals the limit as h approaches 0 of f of a plus h minus f of a over h. Okay? And that's always going to be the slope of your tangent. And you'll notice that this looks very familiar to the instantaneous rate of change that you did last semester, but we're introducing this limit system so that we don't actually have to do those table of values. Okay? All right, so we've got 4 examples down here, all different points with different curves. But I'm actually not going to walk you through these because what we're going to do is I want you to pick 1 or 2 of them, preferably 2, okay? And not necessarily just 1 and 2, pick them at random. And I want you to, I mean, you're welcome to do all 4 as well. I want you to try them out, okay? And the idea is when we come to class, you're going to all split up into groups based on which ones you did, and we're going to take them up individually and see what we come up with, okay? All right, I'll see you next time.